Okay, so let's get started. Sine law, cosine law. This is basically what you need to know for this next chapter test. Sine law, cosine law. If you can do it, you've passed the tests already. Okay. So, who knows the formula for sine law? Who knows the formula? Yeah? Kelly, I think you know it. There's two different ways to write it.
So A divided sin A equals B divided sin B equals C divided sin C.
Right. Okay. What are lowercase letters again? Side lengths. Okay. And what are uppercase letters? Angles, right. So notice it's a pair like this. A over sine A equals B over sine B, or equals C over sine C. So the ratio between all three is the same. Now to do a fraction equal a fraction, I only need 2. So I could use the B side equal the C side, and then do cross multiply and divide. Or I could do the A. So it depends on what you're given. So, but you only need 2 of these fractions at a time. So normally we write it this way. Do not be surprised if you see it being written this way. Can I write it this way? Can I write it this way too? Yeah, it's the same ratio. So just like if you do 1 over 2 equals 1 over 2 equals 1 over 2, it's the same as saying 2 over 1 equals 2 over 1 equals 2 over 1. So both works out the same. Normally we use this one. Okay, but I just wanted to show you guys, if you see this somewhere in another textbook or on Google, it's not you, it's it's the math. Okay. When can you use the sine law then? Yep. Yeah, you need to have a pair when you're given a pair of info and one other info. Okay, so a pair with a length or an angle. Okay, but the key is to use sine law, you have to be given a pair of info. Okay, so let's try example 1 right here. Given triangle ABC. So let's just draw any triangle ABC. Does it have to be right angle triangles? Does it have to be a right angle triangle? No. So if it's right angle triangle, we can do SOHCAHTOA. But now we're trying to do it with non-right angle triangle. And so that's why we have sine law, cosine law. So let's just say I call this angle, yeah, that's fine. Okay, let's say I draw triangle ABC like this. Angle B is 21 degrees. Doesn't look like it, eh? Is that what you were going to say?
No.
Okay. No. It could be obtuse triangles as well. And on Wednesday or Thursday, we'll talk about that more. Okay. So I'm just gonna switch this up. I'm just gonna switch the letter up because this doesn't look like a 21 degree angle. So I'll just call this ABC like this. Okay. Sorry. So B is 21 degrees. So since I say 21 degrees, I know I'm talking about an angle. So the corner right here. C is 46 degrees. So this 46 degrees right here. And then C is 9 centimeters. Where do I put this 9? I know it's on length because it's 9 centimeters. But how do I know which side I put it? Hazel? Yeah, that's right. So angle C, length C is the one across from it. So this is 9 centimeters. Okay.
How's my binder measure?
Okay. Can I use the sine law? Can I use the sine law to solve this triangle? Okay. Thanks for talking about math and not science in a math class. But Hemio, can you answer this for us then? A math question. Can I use the sine law in this triangle?
Yes.
Why?
Well, because you have a pair of angles and you also have an extra, like the 9 centimeter side.
Yeah, I'm given pair C. So yes, I can use C. Okay, what's the other angle that I'm given? Yeah, angle B. So I could use angle B to help me find. Oh. Yeah, length B. That's right, Kelly. Thank you, Kelly. Yeah, that was totally all Hemia. Okay, so I'm gonna use this then. B over sine B equals C over sine C. Right? Length B, that's what I want to find. Sine angle B, which is 21 degrees. And then length C, 9 over sine C, which is sine 46. Okay. Once you get to the second step, actually, this is the first step, setting it up. Second step, you should only have one unknown. Okay, so remember, if you have two unknowns after you set it up, it means you missed something. Okay, so make sure you should only have one unknown, which is the B right here. That's what we want to solve. Okay, cross multiply and divide. It's just a fraction equals another fraction. Sine 21, as you guys know, is just a 4 decimal place decimal. So cross multiply and divide. So B equal 9 times sine 21 degrees divided by sine 46 degrees. Okay. You can do it all on your calculator. So 9 times sine 21 degrees, press the equal sign, and then divided by sine 46 degrees. And you get this. So rounded to 1 decimal place, it means 4.5. What's my unit? Centimeters, because it's a length and because you were given centimeters in the diagram. Okay. There you go. Now, let me ask an extension question. Can I solve for angle A and length A? Who says yes, I can solve for length A and angle A? Who says no, I cannot? Okay. Aryan, why can we solve for angle A and length A, but I'm not given this pair?
You're given the ratio already and you know exactly. So sorry. You can find out angle A quickly by just using 180 is equal. So all the angles in the triangle are equal to.
That's right.
Just use the ratio to find out.
Perfect. Okay. So yeah, I didn't give you A, but think back to grade 5, 6. You know that the three angles in a triangle add up to 180. So you are actually given angle A. So once you have angle A, you can just do sine law again to find length A. Okay, so essentially we could solve for everything in this triangle. Good. All right, example 2, given this diagram. So Henry already pointed out the mistake in this diagram. What is the mistake? Henry?
It's like the side lengths are labeled. Like usually it's the one opposite of the angle. That's the corresponding letter.
Yeah. So this should be A, this should be B, and then this should be C right here. Especially since we're using sine law, this definitely is a big mistake. Okay. So the angles should definitely match the length. Okay, so if you can make those little changes on your diagram. Okay, so now this one I want to solve for everything, solve for all unknown. So am I given a pair? Hazel? Am I okay, but remember a pair is an angle with the opposite length. So in this case, am I given a pair of info? Am I a pair? Good job. Yeah. I'm given the angle A and I'm given length A. So I could use sine law. So A over sine A equals which pair can I solve for? Yep. B? Are you sure? C, yes. Because B, I don't know both. And I don't know angle C. So I have to solve for this pair first. So A over sine A over C over sine C. Okay. So A was 8.5. Sine angle A, 71 degrees. C is 9.3. And sine C is what I don't know. Okay, so again, after I set it up, I have only one unknown here. My unknown is angle C. Okay, cross multiply and divide. So sine C equals 9.3 times sine 71 degrees divided by 8.5. Because when I cross multiply, I have this times this equals this times this. And then when I want to isolate sine C, I divide it by 8.5. Okay. Notice I kept the sine C right here. Okay. So multiply 9.3 times sine 71 divided by 8.5. I get this number. Uh-oh. That's not good. Did I make a mistake? Or is this a sine 71 times 9.3 divided by 8.5? That's not good. Okay, I need to change some numbers. I took this diagram off the internet and the numbers don't work. I need to make this a smaller number. Let's make it 6.3. If I make it 6.3, would it work? 6.3 times 571. Yeah, okay, that will work. Okay, sorry guys. Can you change this number to 6.3?
Wait, I have a question.
Yeah.
How do you write when two triangles are similar? What's the sign in this?
Squiggly line.
Two squiggly lines?
Just one.
Oh.
Two squiggly line is approximately. So one squiggly line is similar. Okay. So when I do this, 6.3, 6.3, 6.3. Okay. I get this. So sine C equals 0. How many decimal places should I take? 4. Good. 7008. Okay. And we did this in the last chapter. You did a whole test on it. How do I solve for the angle now? Yep. Yep. Sine -1 or the formal name. Inverse. Yes, inverse. Okay. So second sine, you get the inverse 0.7008. And you get this when you round it. I just chose really bad numbers. Okay. You round it to 45 degrees. That's fine. So C equals 45 degrees. Okay. So now that I have C is 45 degrees, the question does say solve for all unknowns. That means at the end, I should have answers for all 3 angles, all 3 lengths. What's the easiest thing to solve for now? Yep.
You can just add the 2 angles you have, take that away from.
Perfect. So B, angle B is 180, take away 71, take away 45. So angle B is 180, take away 71, take away 45, 64 degrees. Okay, since it's an angle, make sure you have that degree sign. Okay, 64 degrees. Okay, now what can I do to solve B? What can I do to solve B, length B? Yep.
Use either C over sine C or A over sine A, and you do the same.
Perfect, good job. Can I use SOHCAHTOA to solve for B? Nope, because it's not a right angle triangle. That's why we have sine law. Okay, so A was 8.5 over sine 71. If I had a choice, I would choose A because A is the given pair right from the beginning. If you use C, well, I found angle C. So if I made a mistake, then it will have carry on mistake. So always try to use the given pair. B over sine 64 degrees. Okay, cross multiply, divide. Okay, so B equal 8.5 times sine 64 degrees, and you divide it by what's your unknown, so sine 71 degrees. So B equals 8.5 times sine 64, and then divided by sine 71. You get this, which is about 8.1 centimeters. Okay. I know that when you guys get into the senior grades, your teacher love to get the summary box, the answer box. So angle A, 71 degrees, angle B, 64 degrees, angle C, 45 degrees, length A, even though it's given, 8.5, B, 8.1, and C, 6.3. Okay, so I know in the senior teachers looks for this. So start early, have this, and when you have this, the good thing is you will not forget your units. Okay, so you don't lose silly marks. Okay? And it also reminds you that you did solve for everything. Okay, so there you go. Any question on this example? Any question on sine law? Alright, so I think sine law is pretty straightforward. You can use it on non-right angle triangles when you're given a pair. Oh, so let me ask a quick extension question then. Okay, 5 centimeters, and let's say I'm given the angle 40 degrees. Okay, this, can I use the sine law? Who says yes, I can use the sine law? Who says no, I cannot use the sine law? Okay, I have 2 people in my class. Okay, well, remember, what was the condition to use sine law? A pair. Do I have a pair of info right here? Yeah, what is my pair of info? From 90 degrees and this. This is still an angle. It's still 90 degrees. So, but why? But then I'm thinking, hey, Miss, then we were doing SOHCAHTOA the whole time. So how come? So do I use SOHCAHTOA or do I use sine law? Okay, well, let's see what happens when I do sine 90 degrees.
One.
You got 1. And so, which is the same as SOHCAHTOA. Because sine, because when you do the cross multiply with the sine law, sine 90 degrees is just 1. And so if you set this up like this, like this, sine 90 degrees is just 1. So then it's just A equals that over that, which is SOHCAHTOA. Okay, so that was just an extension question. You can do SOHCAHTOA or sine law with right angle triangles. Okay, on the back, cosine law. So as I was saying, I combined 2 lessons in one today because I'm not here tomorrow. Cosine law. You'll get your chance to practice everything after the 2 examples right here. Who knows what the formula is for cosine law? Let's say you're given triangle ABC using letters ABC. C squared equals.
Okay. C squared equals A squared plus B squared minus cosine.
Minus
Yeah. My bad.
cosine C. Whoa, and then you're thinking, whoa, what are all these letters? How do you expect us to remember all these ABC? What if it's not ABC and XYZ or something? Okay, so we'll talk about how to come up with this equation shortly. Okay, so if sine law, we can do it when we're given a pair. When can we use cosine law then? There's 2 conditions where you can actually use cosine law. All right. So you still have to be given three info. So for example, this right here, I gave you the angle, the length, and this length. So I gave you these 3 things for this triangle. For cosine law, instead of this angle, I would have to give you this angle right here. Okay, how would you describe that there, what you're given? Yep.
2 sides and 1 angle.
In between, that's right. Okay, so we want to make it sound fancier. We're going to say 2 sides and the contained angle. See how much fancier that sounds? It has to be the contained angle, or aka the angle in between. Okay. If it's not the angle in between, then it will mean sine law. Okay, so 2 sides and the contained angle. So x, y, and this angle. Okay. What's the second condition that we could use cosine law? When you're given not all 3 angles, all 3 sides, right? When you're given all 3 sides. Okay, so those are the only condition when you can use cosine law. So for every triangle, it's either sine law or cosine law if you're given at least 3 pieces of information.
What is that? Like all 3 sides? Oh, you're given all 3.
Yeah, given all 3 sides. Oh, given either 1 or 2. All right, so example 1 right here, solve for x, solve for this side. Looking at this diagram, should I do sine law or cosine law? Yep, cosine law because I'm given 2 sides in the contained angle. So let's substitute our letters in this formula. But wait a minute, this is ABC. I'm given triangle XYZ. Okay, so let's rewrite our formula. Looking at this, does this look familiar? What does this remind you of? Pythagorean theorem, yeah. So that part, we drilled it in your head already, so that's good. So notice side C, angle C. So whatever you are solving for, that you always start with that letter. So in this case, I want to solve for x. So I'm going to start with x and end my equation with x. So x squared equal, well, we just said the first part was Pythagorean theorem. So x squared equals y squared plus z squared. Okay. This part should be nice and easy to remember. There's only 3 letters, so if it starts with x, that is x squared equals y squared plus z squared. Take away 2 times these 2 letters. So yz, and then cosine. And there we go. Okay, so not too bad. That's how you write it. There's not really no memorizing. Okay. So now we can sub in the variables. What is this letter? What's the 28? Is the 28 x, y, or z? Yep, z. And the 22? Y. Okay, so sub it in. X squared equals 22 squared plus 28 squared minus 2 times 22 times 28. Cosine, do I know the angle? Yep, 97. Okay, how many unknowns do I have after this step? Just the one. And we're solving for x. Okay. So this part right here is all putting it into your calculator again. Just be very careful. This -2 part right here, this could give you a positive or negative number, and then it could change this minus sign. So let's say I'm doing this all in the calculator. So 22 squared plus 28 squared minus 2 times 22 times 28 cosine 97. Okay, when I press it all, I get this 1418.143. So how do I solve for x now?
Square root it.
Yep, okay, square root it. That's right. So x equal square root that. I get 37.7. And my unit, centimeters, because it was a length. And there we go. So that wasn't so bad. Right, so once you build that formula, it's just a matter of subbing in the letters. Okay, let's try this one. Given triangle QRS and these length, solve the triangle. I'm just gonna draw a random triangle. Okay, I don't want to draw a right angle triangle. And then so S R. Okay, so QRS, something like that. Okay. Length Q is 8 mm. Length R is 10 mm. And length S is 15 mm. Okay. So, sine law or cosine law? Andrew?
You're gonna use cosine.
Why?
Because you don't know any of the angles.
Okay, and I'm given all 3 sides. Right. Okay. So pick a letter. Which angle do you want to solve for first? Q? Okay. Kelly chose it. She says, let's solve for angle Q first. All right. If we're solving for angle Q, what letter do we start off our formula with? So Q. Start with Q and with Q then. So who wants to try writing out that formula? Okay, since we're solving for Q, we start with Q and with Q. Who wants to try writing out the formula with Q, R, and S? Hempio, why don't you give it a try? Hempio? Sure. Oh, it's okay. So Q squared would equal to? No, the letters. The letters. I want the actual letters. Like R squared plus. Good. Minus. Uh-huh. Cosine. Yeah, that's it. Okay. And then again, once you have this set up, it's just a matter of subbing in the letters. So Q is 8, R is 10, S is 15, and then 10, 15, cosine. Do I know the angle? No. All right. By this step, only one unknown, which is angle Q. All right. So now this is the part where a lot of people make the mistake. Can I just simplify all this on the calculator? No. Why not? Okay, order of operation. Adding, multiplying. So I can't combine this all together. So what I would do, I can subtract these two. Yeah, that's no problem. Yeah, I can divide. I can move that and that over, but I cannot move this yet. All right. So 64 minus 100 minus 225. I get negative 261 equals, what is this? Negative 2 times 10 times 15 is negative 300 cosine Q. Yeah. So right here, I can only move these two over first. I cannot do this part. This and this is two separate. Okay, make sure you do the math separately for these two. Okay, and then now I can divide. See, you don't subtract, you divide. You divide that by 300. So negative 261 divided by negative 300, you get 0.87 equals cosine Q. Okay, do the inverse. So Q equals cos inverse 0.87. So cosine inverse, you get 30 degrees. So this is like the number one mistake that people always do, is that they do square plus square, subtract this all in one. Like this is, I always see some people do that. Remember, you can only move the two square parts over first by subtracting. And then this part you divide.
Why do you move it like that? Can you just input into calculator?
You can't, because you don't know what this angle is. If you put all this in your calculator, your order of operation, you can't. This part is multiply. So notice when you move this over, you divide it. You didn't subtract.
Isn't that like, can you just input everything except outside?
Yeah. But the key is, like, you have to. I wanted to show why you're dividing this rather than subtracting this. So if you want, yeah, you could do q squared minus r squared minus s squared divided by negative 2 rs.
Can you just input everything on the right side except cosine q?
Yeah, but as long as you remember that this part goes all together in your denominator. Yeah. Okay, so now that I know this is 30 degrees right here, okay, how do I solve for length s, for example? Okay, to solve for s, do I use sine law? Do I use cosine law? Yeah, you could. I was hoping that some people would raise up their hand, and then I would say that, yeah, you're both right. But nobody put up their hand, so everybody's wrong, except Fabio. Oh, I see. So who says you can use both? Yeah, participation. Good. Yeah, so you could use both, because now I have a pair, and I am also given all three sides. So I could use either or. Who thinks sine law is easier?
Sine law better.
Who thinks cosine law is easier? Who says they're equally the same? Okay. See, I asked for the third option this time. So I personally also think sine law is easier. So I'll just do sine law here. So sine, so 15 over sine s equal 8 over sine 30. Okay. So cross multiply and divide. So sine s equals 15 times sine 30 divided by 8. So s equals the inverse of that. 15 times sine 30 degrees. Oops, 30 degrees. Divided by 8. And then sine inverse. I get 70 degrees. Okay. And then what's the easiest way to solve for angle R? Who says do sine law? Who says do cosine law? Who says do an easy grade 5 method? Okay, and just for Aryan, who says I can do any of the three? You could, but obviously we want to save time, the precious test time, and just do the simplest method, which is 180. Take away angle S, take away angle Q, and R equals 80 degrees. Okay, don't forget, your teachers love to see this box. So angle, so length R, length Q, 8 mm, R is 10 mm, S is 15 mm, Q is 30 degrees, R is 80 degrees, and S is 70 degrees. Okay, I know you're given 3 sides, but it does make your math looks a lot nicer, more organized when you list all 3 sides and all 3 angles. And then you can be sure that you didn't miss anything. Okay, so last example. We're not solving this. It's just a simple question. Would you use sine law or cosine law to solve this triangle? Okay, so take a look at the diagram.
Yeah, sine law.
Okay, who says sine law? Who says cosine law? Who says we can't solve this? Okay, those who say sine law. I thought we have to be given a pair. Aryan.
You can just do the easy grade 5 math.
Yes. Perfect, right? So even though I didn't tell you what C is, because we passed grade 5 math, yes, we can figure out that C is 32 minus 47, 101, even though it doesn't look like an obtuse angle. All right, and then we would be given the pair. So then, yes, it is. Sine law it is. Because once we find the angle C, we can use sine law. Hi.
I always wonder, why do we sometimes just put the E there?
Oh.
Is it just
It's short form. Just like cosine is not cos. It's actually cosine, where we drop. Does it stand for anything?
Make it SIN.
But then when you do cosine, it will be COSIN as well. And then it will be like cosine. Yeah, so it doesn't sound right. Cosine. And then tangent would be still tangent. I think these are Greek words, aren't they?
I do need to know that.
Latin? Greek? Yeah. Greek?
Probably.
I don't know. You can study the history of math. Okay, so that's the lesson on sine law and cosine law. Normally I do it in 2 separate days, but now I concluded in a 42-minute. How is it? Is everybody okay? Any questions? Okay, so try these ones out. The question got cut off. So it was solve for the triangle. So solve for triangles 3, 6, and then 1, 4, and 6. Okay. So for these ones, it's solve for the triangle, meaning all 3 lengths, all 3 angles. Okay. That's it.
I don't even know that.